Hello, I'm Joe Giuliano, and today I will be presenting Lab 1 Charge Tape. Here's our introduction. So in this lab, tape was charged to observe the principles of charges in excess charge. And we did this to observe the interactions between charged pieces of tape and determine the approximate excess charge on one of the charge tapes. And to visualize this, we created a computational model in GlowScript, which shows the electric force and gravitational force counteracting each other. Here are the principles we used in this lab. We used Newton's second law, Coulomb's law, and gravitational force. And then we created a GlowScript computational model. Here are the equations we ended up using in this lab. We used F net equals ma, or Newton's second law, which shows us how a system's change in momentum is proportional to the net force applied to the system. We also used Coulomb's law, which is the formula above, that shows the equation between the attraction and repulsion of two charges. And we have the gravitational force on the right. So here are our initial conditions. We have our 0.1 meter long piece of tape. We have our 1 times 10 to the negative 4 kilograms per meter mass. We have our 0.02 meter distance between the two tapes. And then we have our magnitude of the gravitational force and magnitude of the electrical force as shown here on the right. So here's the experiment. We have a video for each of the two parts of this experiment. So what that shows is that the tape is attracting to the table and repelling from the hand, or attracting to the table and attracting to the hand. And then second video. So we use the bottom tape to push up the top tape through the electric force, and then we used a meter stick to measure the height. And we have our steps on the right. Here's our experiment code that was created in GlowScript. In the top right, we have our code initial conditions, and you can see all the names that correspond to our initial conditions there. We have our calculation loop, which is pretty much the rest of the code. It helps us get our data that you will then see on the next slide. But on the left, you can see what this code created, which is showing how the bottom tape and the top tape, the bottom tape exerts the upward electrical force on the top tape, and then there's the gravitational force that affects the top tape as well. And so here's the data that was produced. We have the charge of the tape. We have the number of electrons lost on the tape. We have the number of atoms for every electron lost. We have the electric field at tape B due to tape A. And we have the electric force on tape B. And here's our discussion. The first question is, what if electrons had positive charge and protons had negative charge? What would change about the observations you made with your tapes and other charged objects? And what I said is that if electrons had positive charge and protons had negative charge, then they would attract to each other. And this would mean that the tape would be attracted to the table and still repel from the other charged tape. And why? Why is it important to handle the charged tapes as little as possible? This is due to a phenomenon called grounding, which is when the charged tape comes in contact with something that's connected to the ground, and the charged tape loses some of its charge because that charge is then directed through you to the ground. To conclude, we had two pieces of tape that were charged and utilized to measure the electric force generated by charging these tapes. And we used a computational model in GlowScript to display the equal and opposite gravitational electric forces. Because both the tapes are of the same charge, they'll repel. And we found that these are positive charges, and so they will repel. And here are assumptions and sources of error. Thank you.